So my last talk today is about using DTrace to observe not just your application, but the entire stack. So I have everything, your application and everything else it runs on using DTrace. So we've got this picture here sort of graphically depicting what our runtime environments might look like today. When I talk about everything else it runs on, you have your operating system. That may be Solaris, Linux, Windows, whatever you're running your app on, or at least developing your app on. And then you mostly have some sort of database in play, Oracle, Postgres, MySQL. And then you probably have a container in play, something like Glassfish or WebLogic or something like that. And then there's presentation layers you can use, JSPs and Ajax and JavaFX. And then on top of that, there's frameworks you can take advantage of. And a lot of times you end up writing just a couple lines of code. And underneath the covers, there's all this code generation or this framework in place to do all kinds of fancy things on your behalf. So that's all well and good, but it's also frustrating if you're trying to do something and it's not behaving as you'd suspect or it's not performing as you'd suspect. So how can you actually get into the virtual machine, whether it be, all of these dynamic languages run in a virtual machine, Ruby, Python, PHP, Java, of course, or even if you're using native apps, whether it be C or C++, how can you get in under the covers and take a look at what's going on? That's the premise of this talk. And so what I've gone ahead and done to do something somewhat realistic is I've installed Drupal. Do any of you in here are familiar with Drupal already? A handful of you. Okay, that's fine. It's not necessary for this presentation. Drupal's a content management system, open sourced. You can use it to create a website and have blogs and comments and all kinds of cool things. But it does sort of take advantage of this stack architecture. So I'm running it on Open Solaris 2009-06. I have the AMP stack installed, so that includes MySQL, it includes Apache, and then Apache's running the Zend engine, or the Zend interpreter, to render my PHP. And then there's the Drupal framework on top of that, which is, so we've got all these components involved, and we're going to work with them today. So just quickly on the AMP stack, again, whether you're developing on Linux or Windows, as a developer, you kind of need a set of components today. And so what we've tried to do at Sun is actually create this stack for you. So specifically for Open Solaris, we've made it pretty easy to install. It's a single package that you install, and we lay down MySQL, we lay down Apache, PHP, and all this stuff that you need, development tools, to begin working quickly on an AMP application. Okay. So Drupal, quickly, I have it installed. And also, if you want to install Drupal, it's very easy as well. If you, I actually wrote a blog on it. It's so easy. It's called the Drupal demo, or Easy Drupal demo. If you Google that, you'll find my blog where I talk about how to get Drupal up and running in literally a matter of minutes. It's a simple install. It takes care of everything. And so I haven't really, this is sort of the generic install. I haven't done anything, but it's got some basic commands where I can administer the system. I can view different reports. I can create content. And so there's enough there to allow me to give you this presentation anyhow on what's going on with Drupal. All right, so as a developer, you may, at one time or another, had these sort of questions. Probably, how much time am I spending? So your application is running. Whether it's running in production or you're testing it, you want to know, how much time am I spending in the various components of my stack? How much time am I in Apache versus the database versus, the PHP engine? Now, if you know about Drupal, the way Drupal works, I'm not a Drupal expert. Again, it was really easy to install, and I thought this makes a good example application for this presentation. But from what I do understand, it is an extensible framework. You can add additional modules to do additional things. It's been designed that way. And so as Drupal is very modular and it's running, maybe you want to know which Drupal modules are taking up the most time. And again, try to abstract Drupal out of this question. I'm just using it as an example. This could be any application. You want to find out what components of my app are taking up the most time. Drupal also has, when you extend it, these hooks that you plug into. And so maybe you want to know, for example, what Drupal hooks are the most expensive ones to use. And so as you're coding your module, you can be aware of, wow, if I decide to use this hook, I'm going to pay a bigger penalty than maybe a different hook. So the big game hunt, what happens today? I don't know if you're a developer or a system administrator, maybe you're somewhere on this chart, a user, I don't know. But as a developer, the app's not performing like you'd like, or the user, and so you go to the sysadmin. You say, I'm going to ask him why this isn't performing as I suspect. And he's like, I don't know, that's not my area, man. Go talk to the database admin. And he sends you there, and you talk to him. He goes, I don't know, go talk to the developer. And I'm like, I am the developer. I came to you for answers. And anyhow, you can kind of get in this big circle. And so part of my goal today is sort of to enable you, whether you are the developer or the database admin or the middleware expert, whatever, to do some investigation on your own. And so traditionally, how you would investigate a performance problem or any sort of problem. You just want to, it doesn't have to be a performance problem. It's a bug you're seeing. You just want some insight into what's going on. What you would typically do would sort of stop the application. And a lot of frameworks like Drupal do provide debugging flags that you can enable. And they're not usually enabled by default because there's generally a performance penalty to turn them on. But you turn them on, you restart your application, you get some information. So that might work for you. Maybe it won't. The problem is it's only at that one layer. You might have to do the same thing at the MySQL layer, and maybe the same thing at the operating system layer to try to troubleshoot where your problem is. Or maybe that's not giving you enough information, so you decide you're going to write some custom code. We've all done this, wrote in custom debugging code, and so you write your code, and that's not too bad with PHP because that's a dynamic runtime. So you can write your code and insert it, and it'll take effect immediately. But if you're dealing with a C or C++ app that's compiled, well, then you're talking about recompiling your code. So here we are. Please let me observe a live system. I don't want to have to recompile anything. I don't want to have to set any flags and restart anything. My users aren't going to want me to do that. Again, maybe the system's working okay, but it has some quirks you want to identify. It's not a critical situation, but you would like it to perform a little bit better. But you don't want to take the system down to do it. So again, we come back to our picture, and maybe you just want to see the SQL statements that are being generated. Again, a lot of times, these frameworks abstract that out. You tell it to do something, and it generates a SQL statement. And you're like, I wonder if that SQL statement's actually efficient. And so how would you query the database to do that? And the database certainly provides means to get at that information. There's logging you could look at. But what's a uniform way you could get this information? Or maybe from the presentation layer, you have some questions as to what's going on there. Again, are there tools within the presentation layer you turn on, or is there some uniform way you could get at this data? And so what I'm here to present to you is that all of this is possible with DTrace. Do I have any DTrace experts here? I think that's my next slide. So how many of you have heard about DTrace in the audience? It stands for Dynamic Tracing. All right, so most of you are brand new to DTrace. That's fine. I'm here to introduce it to you. About 20% of you have heard it. So those of you that have heard about it, how many of you have used it? Okay, a couple of guys, really. So it's great. You're all pretty new to this. And then you've written descripts, I assume. You know what those are. All right, great. So we're going to start with what's known as the D language. It's the basics of instrumenting your applications. And it's pretty simple. You're going to have, basically what you're going to do with DTrace is you're going to write a little script that's composed of at least one part, which is the probe you want to enable. So all throughout the stack, dynamically, we can go in and enable probes that will tell us information. So that first yellow line, where, that would be in Apache, in PHP, in MySQL, in OpenSolaris. We specify what probe do we want to turn on. And then once we enable that probe, the action, I'm skipping over the middle part in red there, the action is, what do you want to do? What information do you want to collect? What do you want to know about? We record that in the action. The predicate allows us to get a little bit more selective. You can think of it like an if statement. So if I've enabled a probe that's going to fire every time I enter a particular function, maybe I want to only fire that probe if that function is entered when a certain executable is called, or some decision criteria that restricts the amount of times that that probe is actually fired. So from the command line, that's mostly what I'm going to do today, is execute DTrace from the command line. It basically looks like this. The command is DTrace, straightforward enough. And then to enable the probe, you use the -n flag, and then you specify the probe you want to enable. That's the minimum that you need. Now, if you want to provide an action, you put that in curly braces. And if you would, in addition, want to provide a predicate, that if statement, you put that in /. So let's take a quick look at DTrace. All right, the first thing I'm going to do is look at just the probes that are enabled to be the probes that exist on my system that I can currently enable. So I'm going to list the probes. And I put the more, I pipe this to more because there's quite a few. But what you're seeing in this output here is the 4 components that make up a probe, which I believe are on the other slide. But there's the provider. Who is providing these probes? So it'll be things like PHP, Java, stuff like that. And then within the provider, you may be more subdivided into a module. That's sometimes optional. You won't always see a module specified. But then you'll have a function. And that generally ties to a C function or a Java function or a PHP function or whatever it is you're probing. That function name is usually a one-to-one map to that. And then finally, the name entry is what are you doing with that function? We've entered it. We've exited it. We've experienced some sort of error in that function. When that event occurs, that's when the probe will fire. And so just looking at each probe has an ID as well. That's this column on the far left here. It's pretty irrelevant. You never have to worry about the ID. But let's look at 229. That's FBT. That stands for function boundary trace. What this means is that any C function in the entire operating system I can trace. And so this function SMB read, SMB is server message block, I think. Whenever a read happens and that function is entered, I could fire a probe. So we can page through and kind of look at the number of probes on the system. And I could tell you we'd be here quite a while. So let me show you. I'm going to run a word count command. 64,000 plus probes I could enable. That's mind-boggling. I mean, I don't know where to begin, right? So don't worry about that. I'll talk about how to figure out what you want to actually enable in a moment. So let's look at something simple like we'll do DTrace, and we're going to enable the probe now. And I know there's a probe called exec success. Anytime an executable is successful, fire. Let me know. So I'm going to go ahead and enable that probe. Right? So it tells me it matched one probe, and now it's waiting for executables to fire. And one just did. I don't really know what it was, but we'll get to that in a moment. Oh, look at that. I started up another GNOME terminal, right? I had like 6 probes fire. Let's do something just like run ls. There, that caused another one at least to fire. So, all right, kind of cool. I see something's happening, not very useful at the moment. And this is where the action comes in. So I've just enabled the probe, but now using the action, I can actually get more information of exactly what happens. So let's come back here. I need to put this into single quotes, and I can say, I want to see, there's a couple of variables that DTrace gives me access to. One of them is executable name or exec name. So what I'm saying here is, whenever this probe fires, I want you to tell me the executable name that caused that probe to fire. Okay. Now I'll run ls again. What's happening? What's that? Oh, thank you. Yes. It's always good to have someone in the audience who's done this before to help me out. Thank you. So, right, there's two ways that you can get the value of the variable. So I was just putting the variable there. I wasn't telling it to display. I can use a printf command. If you're a C developer, you're very familiar with printf. Or I can simply use trace, which will spit out the value of that variable. And so let's try that again. Okay. There we go. So now I ran ls, and you're seeing it's telling me, so exec success, and then I see ls and hostname. What's up with that? Why did it display the hostname? Exactly. It's the prompt. My prompt has hostname in it. My hostname is OpenSolaris, and it's in the prompt. And so if I set my, let's do, if I just set my prompt to not have the hostname, and then I run ls, then that's all I see is ls. So it no longer needs to call hostname. Let's get out of here and start up a new one. Now, I talked about predicates. Let's run let's run this again. All right, now I've got hostname back in my prompt. So every time I run ls, it's going to show me the hostname. Say, for whatever reason, I didn't want to see when hostname fired. I didn't care about that. Well, that's an example of where I could use a predicate. So I could come in here and say exec name does not equal hostname. There. And now that probe has just been prevented from firing. That action doesn't actually happen anymore. Okay. So some other cool. So let's look at some other probes. Let's look at one called system calls. System calls are very common on the system. A system call is anytime an application is calling from what we call userland into the kernel. That's a system call. So I can, for example, see all the system calls that are happening on the system. And I'm going to say, whenever we enter a system call, and I'll do a, let's see. Okay, now this is just crazy, right? It's just like, it's unbelievable what is actually going on in the system live as I'm not doing anything, and the system's going bonkers, and all this stuff's going on, right? So I've been doing everything from the command line, and that is how I'm going to do most of this presentation today, but DTrace can be put into a file. It's known as a D script. So I have, for example, a syscalls.d file. And let me put that a little higher up for you. So it looks very much like this. You have the probe that you want to fire, and then you have, in this case I'm using a printf statement instead of the trace, because with printf I can get a little bit more fancy about what I print. And notice I have a pretty funky predicate here. I'm saying all kinds of things. I don't want to see where the process ID equals the process of the application I'm running, which happens to be DTrace. I don't want to see any of those system calls. Or I don't want to see any of the system calls where the executable name is xorg. So, and then to run that, you would simply say DTrace script one thing I want to show you really quick. Notice it said at the top, I don't even know if I might have not, so many system calls happened, I probably missed it. But it matched 235 probes were matched. Even though I put a predicate on there to eliminate some of the probes that are firing, it's still going, crazy. There's all kinds of activity on my system. Okay. So just some examples of predicates you might use. These are variables that are available to DTrace. For example, if you want to know, if you only want to see the activity on a given CPU, you could specify that. Or a given process ID, whether it equals or does not equal, you can specify that. Or a given user ID, you want to see what Leonard's up to, you could specify that. You saw me use executable name. There's equals, does not equal. You could have multiple predicates with and or. And there's also variables, $PID, process ID. You can actually pass a process ID into the DScript. All right. So we saw this huge flood of data coming out. Is that really useful to us right now? We thought, man, okay, there's a lot of system calls going on the system. How can you give that to me in a more user-friendly format, something I can do something with? And for that, we use what's known as an aggregate. It allows us to actually, we let the script run, and it uses some sort of function, such as count, to total up what's happening on the system. And then you have to decide what you want to count by. So say we want to count by executable. Exec name. I believe that is correct. So we'll run that. Okay, there you see it matched 235 probes, but we don't see any output anymore. It's collecting in the background until I cancel. Now, I don't even have to do anything on my system, and I'll Control-C out of this, and you see, bam, I got this whole huge list of output. And you see Xorg is at the top of that list. There was 6,700 system calls made in a couple of seconds that was run, followed by DTrace itself. So say we wanted to drill down and see, well, what's Xorg up to? So that's where we could put a predicate in here. And then instead of counting across executable name, maybe we want to see the C functions that are being called. So I can use like probe function. I'll count the probe functions. Okay, we'll let that run. Okay, and there we go. So now we're starting to drill down. So maybe this is what's the beauty of DTrace. I was actually talking to Sanjeev. I don't know if he's in here during the break. He works in the revenue engineering team, basically the escalation team, and they use DTrace all the time. Customers call in with issues, and they just send them a DTrace script. Here, run this and tell me what you got back. And then they get the results, and they say, okay, they write another script and say, here, now run this one and tell me what you get back. And maybe they'll go through 4 or 5 iterations, but they continue to drill into the problem. And so here we see we've drilled into the functions that Xorg is calling. And at the very top, or it's at the bottom of the list, but the most heavily called one is clock get time. It was called 5,000 times in those couple seconds. So that's actually a probe function. So let's do this. I'm going to come in here. That's a probe function, so I can put that as part of the probe definition. I can say, well, let's look at clock. What is it? Clock get time. Now, instead of aggregating over probe function, let's drill down and aggregate over the user stack within clock get time. All right, now we matched, look, one probe, right? By putting the clock get time in here as the function, there's only one probe that I'm entering. So we let that run for a little bit. We don't have to wait too long. I cancel out. And now we've got this very helpful hexadecimal output of all my stack traces. So I don't know who's in here is matrix-like, and you can look at this and say, I know exactly what that is. Any guesses at what I can do to get actual readable output? I can run it. The problem is I'm not privileged to see that output. So I can run it as a privileged user. If you were in my previous talk, you know what I'm doing. If not, come see me afterwards. So if I run this again, there we go. And now we're actually seeing, and let's maximize this for, and this list is sorted, just like every other list, is sorted by number of occurrences. So at the very bottom of the list, meaning the most occurrences, I can look through this and these are the actual xsorg C functions that were called, made up this total number, but 1,100 times was this, prepare, composite, exit, try, driver. I don't know xsorg, so this is, the thing about DTrace is it definitely helps to know the application you're tracing. If you don't know the functions you're looking for, it's definitely more challenging. And so, but you could imagine as a developer of xsorg, this type of data might be extremely useful. So you can look at these stack traces and glean some useful information. Okay, so those are aggregates and how they can help you out. So now what I want to do is talk about different providers. Remember, provider is the very first entry in the probe name. And so that we have a provider called the PID, or the process ID provider. And basically, this is so cool. Any application that I run on OpenSolaris, on Solaris, by the way, this is not unique to OpenSolaris. This is a Solaris feature. Any running application, I can dynamically insert probes at the beginning and end of every function, and even an offset within if I specify it. You don't have to do any work. You don't have to recompile your app or anything. All right, we'll take the GNOME terminal. So the GNOME terminal that I'm using right now, its process ID is 3969. So I can say PID 3969. If I want to list all the probes that are available against that process ID, I can do this. All right, this fails because that process ID is, not accessible to my, let's try this.
No, flag. 2835 is the process. Flag.
3969. Wait, what are you saying?
2835 is the process.
283. Oh, you're right. I'm sorry. It's 2838. Thank you. Here, see, that earns you a t-shirt. Did you already get one earlier?
Yeah.
See, that's amazing. I'll owe you one too for helping me out earlier. Come see me after. There we go. Now, this isn't DTrace running. This is just DTrace telling me the number of probes that are available in GNOME terminal that I can fire against. Again, that's a ridiculous list. Let's look at a count. 8,000. What's that essentially telling me? There's, I guess, what's that about 4? If there's entry and return. No, I only did entry. I'm only looking at the entry probes. So that's telling me there's about 8,000 functions in GNOME terminal alone. And I can insert a probe into any one of those. So let's look at something like, what?
Java.
Well, no, yeah, Java's insane. Say I just wanted to look at something that had to do with history. We saw history earlier, right? And so say we wanted to drill in. Just look at the history information that's available. And I got several pages of it. I got history was read, history was added, removed, cleared, expanded. Using history. So let's say we were interested in using history. So that's the function. This should should return one probe. There it is. Good. And so now, by the way, so what I've done here is the L option tells me to list the probes. When I take that off, it's actually going to fire the probe. So there's the one probe, and this is kind of like before, except I'm just grabbing an arbitrary process that's running on my system and saying instrument it. And now if I do ls, we see the history ran a couple of times. And it's kind of like before, I'm not getting a whole lot of information, but I could then use the action command to further augment that and figure out what executable, so on and so forth. But that's the PID provider. And so any process that's running, I could drill into. And I don't know, that just kind of turns me on. I think that's really powerful, just to take a process and start interrogating it with no, you don't have to do anything. You give me some executable and I can start telling you all about it. That's kind of wild, especially if you're a developer. So using this capability, you could do things like query MySQL. And so we're going to use the PID provider. And in this case, what we're showing an example of here is an actual script that was written. And so what's cool about this script, it was made executable. So it's actually going to call DTrace on my behalf. So I just got to execute the script. Now notice it wants a PID$1. What does that mean? What was that?
First argument on the command line.
It's the first argument on the command line, right. So I need to find out the PID, the process ID of MySQL, and pass it in to the script. And what it's going to do is there's an actual function. Now notice there's another new thing going on here, is you can use wildcards when you specify your functions. And so there's a function called dispatch command. Actually, well, let's look at DTrace and see what this function is called. 514.
Command.
Huh? Yeah, you guys are trying to help me out. I needed process, pf exec. I didn't have authority as the normal user to, that's the thing, I don't, so it's not anybody can do this. You definitely need privileges to access these DTrace commands. So my user has to have the proper profile assigned to be able to interrogate these processes, which I do. So I prefix the command with pf exec. Now, look at that probe name. So the PID is obvious, 514. The module, MySQLD, but look at the function name. I mean, I'm not going to type that in. And so this is where wildcards come in really nice. And so that's what I have going on here. I don't, in any place, whether it's in any of those sections of the probe name, you can use wildcards to get at what you're looking for. So that's what's going on there. And so then what we're doing is a printf. Now, over in the dog tags here on the left, I have some information about the provider. And notice argument 2 is, so another new thing we're learning here is the probes also have arguments where they return additional data. So in addition to the standard variables that DTrace provides, like executable name, we can also get back additional data that the probe arbitrarily wants to provide to us. And this is context sensitive. In the case of a MySQL command, it makes very much sense for it to return to me the SQL statement that's being run. And it does this in arg2. And so what we're doing is we're copying the string from userland into DTrace land. That's what the copy in string function is. And then we're going to printf the SQL statements. And so okay, there it is. So here's that same script already on my system that I just showed you online on my slides. And this is executable, so I can just literally run like that. Invalid probe description. Oh, yeah. So PID, thank you, 514. So again, it's expecting the argument. Thank you, just 514. Yeah. There we go. Could have done it either way, but that's fine. So, I don't know. So obviously MySQL is pretty quiet right now. It's not doing anything. Let's do something. I should use a mouse. Okay, so let's start up MySQL, run something like the status command. And so now I'm seeing, if you're curious, what SQL statements underneath the covers, MySQL was running when you ran through the admin tool, things like status. I mean, I don't know how accessible that data is. Maybe it's clearly visible in the log. Maybe it's not. But you can see that I was easily able to get at that information. Or now let's bring our Drupal app into picture. That's running on top of MySQL. So let's just do something like, look at the status report. I think anything you do in Drupal is going to hit MySQL. Yeah, and so that fired off, a bunch of SQL statements, and I can see all those there. And again, I just did that by using the PID provider against MySQL.